Now here I have a domino and a ramp. Domino lying on the ramp, which is lying on a level surface. If I raise this end of the ramp and continue raising it, eventually I'll get to the point where the domino slides. And then it's probably going to slide pretty quickly. It's not going to stay on the ramp very long. Okay. Now, as I raise the ramp, the domino wants to slide down it, to put it very vaguely, but in a way that's intuitively obvious. The domino is going to want to slide more and more, but friction is preventing it from sliding. Okay, so friction is exerting a greater and greater force to prevent the domino from sliding until we get to a point where friction can no longer resist the tendency of the domino to slide down the incline. Now, how can we explain what we're seeing there? Well, we'd start by drawing a free body diagram as explained in your textbook. And here's, let's say, the incline, and here's the domino. What forces do we have acting on the domino? Well, wherever the domino is, gravity is acting on it, and gravity is acting straight down. So we can indicate the force of gravity acting straight down on the domino. Now, if the incline is this way, okay, of course that would correspond to having the incline like so, but clearly then we have a force of friction resisting the motion of the domino. Okay? And then what other forces do we have? If it was just these two forces, then the net force would be down in this direction someplace, the sum of these two forces, and the domino would then accelerate because the acceleration is equal to the net force divided by the mass. Okay, well, that's not happening. The domino is not accelerating in the direction of the force that we would get if we added these two forces. There must be some other force. Well, of course, we know that the incline is holding the domino up. Now, and I'm going to actually go ahead and demonstrate this. The incline exerts a force that's perpendicular to the incline itself. The reason for that is the domino weight tends to bend the incline a little bit or compress the material. Either way, when the incline, say, unbends, it springs back and it's going to push the domino in this direction. Not in this direction, in this direction. Okay, now I've got a meter stick, and the advantage of the meter stick is I can bend it somewhat. So if I bend the meter stick down like this, corresponding to the way the downward force of gravity might tend to make the thing bend, what happens when I release it? Well, the domino went up and out this way. Okay, now if I grab another domino, the thing's kind of hiding under there, and do this again with a steeper ramp. Let's do it again. What direction is the domino going to go? Now, I'm pulling straight down. Okay? I'm not pulling back this way. I'm pulling straight down. But watch what happens now. Okay, domino goes out that way. It's pretty easy to understand, or to believe at least, that it's plausible that that domino was projected off of here in a direction perpendicular to the incline, both in this case and in this case. And that indicates that the ramp, or in this case the meter stick, was exerting a force when it sprang back that was perpendicular to its surface. Now that sort of force is called a normal, excuse me, a normal force. In response to the other forces on it, the incline exerts a force perpendicular to its surface. And these three forces, if we add up their components are going to add up to 0 whenever the domino is stationary. Okay, so for any incline that keeps the domino stationary, that picture is going to give us 3 forces, and the 3 forces are going to have to be in what we call equilibrium. They add up to 0. If we add their components, the components all add up to 0. Now, if we get up here where it's too steep, well, friction does have its limits. So if we max out the friction and go a little steeper, then we get an acceleration down the incline, because these 3 forces can no longer add up to 0. We can't get enough friction to counter the component of the normal force and the component of the gravity, rather the component of the gravity in the direction down the incline. Now, more about that later, much more about that, but that's the general idea. Even more generally, we want to be able to draw these pictures that indicate all the forces acting on an object, and that's the picture that we use as a basis for understanding forces, understanding energy in many situations, and a wide variety of situations that we'll encounter.